Hi, and welcome to this video on derivatives. When we're talking about the definition of a derivative, it's described as the limit as h goes to 0, f x of h minus f of x over h. Now what does this mean? If we take a x and y axis and a curve, to find the slope at that point, also called the tangent or the gradient, we need the y over x, and that gives us the slope or the gradient. In differentiation, what we're concerned with is small changes in y and small changes in x. This gives us a more accurate indication of what the tangent actually is. So, if we draw an enlarged version of this being y and this being x, when we're talking about differentiation, we talk about a small change, or delta y over delta x, a small change in x, or in Leibniz notation, dy over dx. A lot of different notations are used for the derivative. So y prime is used, d over dx is also used, and also f prime of x. These three commonly used to describe a derivative. So if we go back to the definition for a derivative, what is f, x and h, f of x and h? Again, if we draw a xy axis, and then a curve, 2 points on the curve, and then we want the slope of the tangent to those 2 points. We can find this by finding y over x. If we call this x, and this distance between h, the corresponding value for x on the y-axis is f of x, and the corresponding value for x plus h, if we go up and along to the y-axis, is f x plus h. So this value gives us delta y. This value minus this value gives us h. So if we go back to the definition of a derivative, which is the limit as h goes to 0, h being interchangeable with delta x, of f of x plus h minus f of x all over h. This top line becomes delta y, and this bottom delta x, and this equals dy over dx. Now let's have a look at differentiating from first principles. If we have f of x or y equals x squared. So from first principles we remember that, let's put it in a little bubble, f of x plus h minus f of x all over h. So we want to substitute into this y equals x squared. So simply, wherever we find the x, we substitute with x plus h. So this becomes y, when we're differentiating, y prime equals the limit as h goes to 0, x plus h squared minus x squared, which is y, all over h, equals the limit as h goes to 0. Now what we have to do is x plus h squared from a plus b squared, we get a squared plus b squared plus 2ab. You apply that here, we get x squared plus h squared plus 2xh, and then minus the x squared all over h. Here we can cancel the x squared minus x squared, and we apply the limit as h goes to 0, we can factor out a h, two x plus h all over h. Now we can cancel the h's, and we're left with the 2x plus h. Now as the limit h goes to 0, this becomes 0, and we're left with 2x as the answer. So y equals x squared, when we differentiate it, becomes 2x. Now let's have a look at a graph of y equals x squared. As you can see, it's a quadratic. If we graph or plot the derivative, which is 2x, we get this red line. The important thing about the derivative is where it crosses the x-axis. In this case, it crosses the x-axis at 0. It's quite an important part of the derivative. Where the slope equals 0, x equals is where it crosses the x-axis, where x is 0. Take a look at the red line again. If we have a look at a point on the function y equals x squared, say we have a look at 2, we go up to 2 and we find the corresponding y value is 4. So if we look at 4 and corresponding y value 1, 2, 3, 4 will be 8 on the derivative. So this tells us that the tangent or the gradient at 4, x equals 4, is 8. Quite an important thing to bear in mind. Okay, so what we're going to do now is we're going to practice some more derivatives from first principles. If we try to simplify and use delta y over delta x, let's use that now and derive from first principles. For the function y equals 2x squared plus 3x, what we're going to do is everywhere we see an x, we're going to put x plus delta x, and everywhere we see a y, we're going to put y plus delta y. So let's proceed. So this becomes y plus delta y equals 2x plus delta x squared plus 3x plus delta x. So all we've done is replace the y with a delta y and replace the x with a delta x. Now, just to get delta y on its own, we take away the y, so we get delta y equals 2x delta 2 plus delta x squared plus 3x plus delta x minus y. Now what is the minus y? The minus y is nothing but this. So this now becomes delta y equals 2x plus delta x squared plus 3x plus delta x minus 2x squared plus 3x. Okay? Now what we're going to do is open open these brackets, the x plus delta x squared, and multiply out the 3. So this from a plus b squared becomes a squared plus b squared plus 2ab. Applying that, we get delta y equals 2 x squared plus delta x squared minus 2ax minus delta x plus 3x plus 3 delta x minus 2x squared. Now we're going to distribute this minus sign, minus 3x. Here we distribute the 2 into this bracket. We get delta y equals 2x squared plus 2 delta x squared. Sorry, that should be a plus. Plus 4x delta x plus, bring this down, 3x plus 3 delta x minus 2x squared minus 3x. Is there anything we can cancel? Yep, that 2x squared and the minus 2x squared we can cancel. Anything else? 3x minus 3x. Those are like terms, so we can cancel those. Okay, so now what we're left with is delta y equals 2 delta x squared plus 4x delta x plus 3 delta x all over delta x. If we make that delta y over delta x. So we can take out a delta x, which is common. So delta y over delta x, factorizing out the delta x, we get 2 delta x. Delta x times 2 delta x is 2 delta x squared plus 4x plus 3 all over delta x. Now we can cancel out these 2 delta x's. We're left with delta y over delta x equals 2 delta x plus 4x plus 3. And now if we apply the limit, as delta x goes to 0, we get 2 times 0 plus 4x plus 3, which that cancels out, becomes 0, 4x plus 3. So deriving from first principles, the derivative of y equals 2x squared plus 3x is 4x plus 3. 3.